this is first video on your advanced CSAT questions. Let's get started. Now, it says in a 3-digit number n, the digits are non-zero and distinct such that none of the digit is a perfect square and only one of the digit is a prime number. Then the number of factors of the minimum possible value of n. Now, you have seen questions like this in CSAT, correct? You may not have attempted them, but you have seen questions like these. Now, these I'm trying to pick, like this one is from CAT 2025. Okay, so now let's try to approach this question. Okay, so all these questions that I take here are from some other exams that are being conducted, the good exams, okay, like CAT, GMAT, okay, and like CAPF, CDS, all those exams which have good questions and which are relevant to the questions that are asked by UPSC. Those I'm trying to pick. So this is also one question like this. Now, how do you break this down? Please pause it and try to think on your own. I'm not telling that you can solve this or you will solve this, but at least think. Okay, so that your thinking develops, so that you start that I should start like this, I should start the number like this, I should start writing like this. That only will ease you out when you see a difficult new question. So try to do it. Pause and try to do it. Now let me do. Okay, so in a 3-digit number n, okay, so 3-digit, correct? So 3-digit number n now will look like something like A, B, C, correct? Then the digits are non-zero, correct? So now you have possibilities of 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? Now you have these possibilities. Now it says and distinct, so 3 of them will be used. Fine. Then such that none of the digits is a perfect square. None of the digit is a perfect square. So let's remove all the perfect squares. Okay, so I remove 1. 1 is a perfect square. 1 square is 1. Then 2 square is 4, correct? Then 3 square is 9. Perfect squares are gone. Now next, and only one of the digit is a prime number. So any one prime at max I can take, correct? Now it says then the number of factors of the minimum possible value of n. That means what? I have to minimize n. I have to minimize n. Now, if I have to minimize n, what should be the first digit that I use? This you can think. What should be the first digit that I should be using? If this is a 3-digit number, what should I fill here? Such that n becomes a very small number. Can you feel that? Now 1 is not available, so the other smallest number available is 2. So it must start with 2. Can you feel this? Very simple logic, correct? Because you had to make it small, so you put 2 here. Now once you put 2 here, now prime number is gone, correct? 2 is gone because you can only distinct numbers, so 2 is gone, but along with 2, because there can be only one prime number, so all primes are also gone. So 3 is also gone, then 5 is also gone, then 7 is also gone. What numbers are left? 6 and 8, that's it. So now the other two numbers will obviously be 6 and 8 because they have to be distinct. Now if I want to make it small, which will come first? 6 will come first. So this becomes 6, 8, 268 is that beautiful number. Now it is asking you the number of possible number of factors of this n. Number of factors, very easy. 268 means what? Divided by 2. So this goes 1 time, then 3 times, then 4 times. Then next thing, next you again divided by 2, it goes 6 times. 1 remain, with 14 this goes 7 times. So what you got? 267, that is n is equals to 2 square into 67 power 1. Now I assume that you must know this, that is number of factors. So what it will be? Number of factors, 2 plus 1, 2 plus 1, 3, and 1 plus 1, 3 into 2, answer becomes 6. This is the answer. I know it was a difficult question in the first glance, but can you understand it? How I have broken this down? And so this is something that you should start writing. Correct? That will build your confidence. If you keep on just seeing the solutions, just sitting there and getting scared by questions, it won't help. Okay, so back yourself, put your pen on paper. Okay, like nothing, like what I have written here, 3-digit number, so I wrote ABC. Why I have written ABC? Because I say distinct, so I write ABC, correct? Then I wrote, it said non-zero, so I remove 0 and all the possible digits I have written like this. Very simple, correct? And then step by step minimize this that you went. Now let's do another. The sum of digits of this number is. Now this is not a direct question that you have learned that sum of digits you have to calculate like this, that. Okay, now think about it that what you can find from here. Now, at least first thing, whenever you see bracket power something, then first thing you should do is, if bracket has a big number, you should reduce it to some prime factor. Correct? Usually, what they give, they give some power of a smaller number. So here, what is 625? What is 625? 5 5s are 25, 25 5s are 125, 125 5s are 625. So that means this is 5 power 4. Now, of course, this will be multiplied. So 4 into 65. Now, into 128 is what? 2 6 are 2 power 6. 64, correct? 64 into 2, 128. So this is essentially 2 power 7 into 36. Can you feel this? This is fine. Now, 5 and 2, of course, because they are prime, so they cannot have anything in common now. So now, if you ever see 5 and 2 together with some powers, does something strike you? Where have we seen this? When we were counting number of zeros, correct? If you are counting number of zeros in a product, in some whatever, correct? So when you count in product, you're looking for that power of 10, correct? So 5 and 2, whichever is lower, all that, correct? So here also, now the good thing about 0 is, if you are finding sum of digits, so all these zeros that come, there will be many zeros. At least this you can feel, correct? Now if you add them all, it does not matter. It will still be 0, correct? So now all the time that you are getting 0, you can just eliminate it. It does not matter, and whatever remains after that, that we find the sum of. Now 4 into 65 is what? 5. 65 into 2 is 130. 130 into 2, 260 into 2 power 7 into 36. 6 sevens are 42, 4 carry, 7 threes are 21, 21 plus 4, 25. 252 and 260, what you can take, what you can see common, can I write it like this? 5 into 2 power 252 into 5 power 8. Yes, sir. Correct. 252 I have taken common. Now 5 into 2 is 10. 10 power anything. This will always give me sum of digits 0. You want to write, keep it. Otherwise, just leave it. Now you have 5 power 8. Now how do I find 5 power 8? I have to find the sum of values of this 5 power 8. So what I will do? Now, what do I know? I know 5 power 4. 5 power 4 is what? 625. Correct. Now, let me do it here. So 5 power 8 is essentially 5 power 4 into 5 power 4, which is 625 into 625. Okay, now, see, there can be many ways of getting to the answer. Now I am using something that you know as how you multiply things. Okay, so that you learn also that how you multiply two numbers that ends with 5. So if any two numbers end with 5, first thing that you can write here is it will end with 25. You see 15 into 15, 15 into 5, correct? 15 into something something. So like that, you can multiply any number, 5 and 5 at the end. If it is 2 digit, 3 digit, correct? Then what you will get? 25 at the end. Now, for the other part, what you do? You have, let's say, two numbers like this. So what you do? You increase this by 1 and multiply it with this. Correct? So this becomes, increase it by 1. So this becomes 63. Correct? Now multiply it with 62. And this you will put here. Correct? Now this is very easy. If you can directly multiply, it's fine. Otherwise, 2 3s are 6, 6 2s are 12. Then 6 3s are 18, 1 carry, 6 6 are 36 plus 1, 37. So you got 6 and 10 here, 1 carry. So this becomes 8 and 9, and this becomes 3. So what you got? You got 3906. You got 390625. This is that number. Now, what is the sum of digits? Add them all. Add them all. So 3 plus 9 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 plus 5 is 25. 25 becomes the answer. I know there is a shorter method also to find the sum of digits, but I am not using it. Okay, so that you understand how you multiply these, and that ends with 5. So 62 into 63, and you get to the answer, that is 25. Understood the concept? So you see product and you get scared. Think about it. What is this? What can it be written in this? Where you have a small number here always, and then try to break it down. Then it is very easy, correct? Now, let's do another. This one. So what it says, yeah. So it says 3AC is equals to 8 times A plus B. Then the smallest possible value of this. Again, you have seen similar trial and error questions in UPSC. This is better. Now, see how it works. Try to think about it. Try to think about it. Whatever you can gauge out of it. That is a very good habit that you must develop. So you see 3AC is equals to 8 times A plus B. So this becomes 3AC is equals to 8 times A plus B. Now what can you tell me from this? If A, B, C are all distinct natural numbers, if they are natural numbers, then 3 and 8 do not have anything in common. That means A into C must be a multiple of 8. Can you feel this? Correct? There must be a multiple of 8. Also, A plus B must be a multiple that you cannot really tell because you have A and C also. But this you can see very clearly because 3 and 8 is there. So, A into C must be a multiple of 8. Now, any one of them or both of them together, if they can make it, I am happy. Now see. I see here what I have to minimize. 3A plus 2B plus C I have to minimize, correct? Now, if I have to find the smallest value or minimize this, then what should I do? I should minimize A. Can you feel this? A should be very small. Let's try to make A small. So this becomes 3 into, now what can be the smallest value of A? Of course not 0, but natural numbers, so 1 into, now I have put A is equals to 1. Now see, what C has to be? C has to be 8. Otherwise, this B won't be a integer or natural number. Correct. So C must be 8 here. Now, if C is 8, what you can do? 8 and 8 cancel. What you got? 1 plus B is equals to 3. 1 plus B is equals to 3 means what? B is equals to 2. So B is 2 and C is 8. What is the sum? It is asking you 3A plus 2B plus C. So the first value that you got as a possibility is this. So you put 3A, 3A means 3 plus 2B, 2 2s are 4, correct? So you got 3 plus 2 2s are 4 and then plus 8, correct? So you got 7 plus 8, that is 15. This is one possible value. You have to find the smallest. Now let's try for any other number also. Now I take 3 here. So instead of 1, what other number can I take? That I have to see, correct? So I take 2 here. Then I don't know what is C, and I am writing here 8, 2 plus B. Now, if I take 2 here, what can C be? C can be 4, correct? Or C can be any bigger number also, but bigger you don't care. Why you don't care? Because you are trying to find the smallest value. So why you will take a bigger number then? If you take bigger number, let's say you take 16 here, it satisfies, correct? Some value of B also you will get, but that will be too big. You want small values. So what is the minimum thing that can satisfy my equation? So instead of C, I write here 4. So that 2 into 4 becomes 8. Now I cancel 2 into 4 and 8 cancel. 2 plus B is equals to 3. So what I got? B is equals to 1. What was the value of A that I had taken? A I had taken 2. And what I got is C. C was 4. So these are the three values, 2, 1 and 4. Now let's check this also. So you put 2 here, 3 2s are 6 plus. Now 2 1s are 2 plus. C is 4. So what I got? 6 plus 2 is 8. 8 plus 4 is 5. Got it? Now, can I try for any other number? See, if you tried any other number, for example, let's say, now you have tried 1, you have tried 2. Now, if you go for 4, don't you feel that if this is 4 and this is 2, then essentially your A is actually becoming bigger than your C. So here, if I put 4 and 2, now you just see 3 into 4, this itself becomes 12. And then you add C, C that is 2. So 12 plus 2, 14. So anyway, this becomes a very big number. Similarly, if you take any bigger number, it will always give you much bigger values. So what is the smallest? The smallest that you got is 12. Answer becomes A. Then let's do one more. Yeah, the sum of all digits of this number is what? Okay, again, very doable question. If you can see it, you can do it. You just have to see this concept we have learned, correct? Just subtracting, finding sums, but you must be able to see it. Now, that is why I say Start to think. Like, I'm not telling you to attempt these questions directly in the exam, but when you are practicing, you should be doing these questions, correct? Because easier versions of this is always made. Okay, and then you are not very sure what to do. Approach is very important. Now it says 10 power 50, 10 plus 10 power 25 minus 123. What to do with this? How does 10 power 50 look like? 10 square is 100. How many zeros? 2 zeros. 10 power 25 will have how many zeros? 25 zeros. So this is 25. This is 25 zeros. Then let's see this. So now 10 power 20, sorry, this is 10 power 25. Now you also have 10 power 50. So let's yeah, let it be 25. Let's see. Yeah, let's make this 50. Correct, same logic. 10 power 50 means 1, and after that 50 zeros. Now how will 10 power 25 will look like? It will look something like this. Somewhere you will have 1 and then 0 0 0 0 0 0. How many times? How many times this you will get? 25 times. This was 50 times. Now first thing, I can add both of them as it is given in the question. If I add both of them, what do you think will happen? See, you will get 0 0 0. How many times you will get 0? 25 times, correct? So 25 times you will get 0. Now here 0 plus 1, what you get? You get 1 here, correct? After that, how many digits are gone? 25 plus 1, 26 are gone. 26 digits are gone. Now 50 zeros were there. Out of that, 26 are gone. How many more zeros? 24 more zeros. Though it does not matter, this is the 0 0 0 0, then 1, and then this. Fine. So this is that number. Now I have to subtract 123. How easy it is. So 1 0 0 0 like this, and then this 1, and then 0 0 0 0 0 0 0 0. How many times? These zeros. Only these zeros matter. Correct. So how many times you have to go? This is 25 times. Fine. Now see. I subtract 123 from it. What I will get? See, subtraction, So this is 10, this will become 10, correct? 10 minus 3 will be 7. Then if this becomes 10, this also becomes 9. See, essentially this, see, all these are zeros. So from where the carry will go? From here. So this one will become 0. Can you feel this? And others, all of them will become 9 9 9 9 9, correct? 9 9, except the last one, which becomes 10. So now 9 minus 2, 9 minus 2, again 7, then 9 minus 1, this becomes 8. Now this one has become 9, but there is nothing to subtract, so this will remain 9 as it is, and then 9 9 9 like this. Now see, this total was 25 digits. Now out of them 3 are non-9, and other how many remain? 22 nines are there. So you got 22 nines, because it is asking you what is the sum of all digits. Sum of all digits. So 22 into 9 plus 8 plus 7 plus 7. So 7 plus 7 becomes 14. 14 plus 8 becomes 22. Correct? So this becomes 29, 22 into 9 plus 22, that is equivalent to what? 22 into 10, that is 220. Now you may start searching for your answer as 220. You won't find. Why you won't find? Correct, there is a close enough answer, but why you're not getting 220 as the answer? Because you forgot this one. If you subtract this one remains as it is, and 0 0 0 like this. So you must add this one also for sum of digits. So add 1, answer becomes 221. That is C is the answer. Understood? Very doable questions, but of advanced level. Okay, so questions of this level. Other chapters like number system is anyway difficult, but other chapters will be slightly easier and slightly more doable. But the tricky questions like this, how you approach them, if you keep doing this series, you will see that you really become good at counts. Okay, and that is the whole point. Just doing those same PYQs, easy questions again and again won't develop your thinking. Once you develop thinking like this, then you can do the easier question that are wrapped in some different paper very easily. Okay, with this I end this one. Thank you. Yeah, hello everyone. So let's do the next questions, that is 5, 6, 7, all these. Again, same concepts that you have learned. This is mainly about remainders. Okay, nothing much, you just have to think a little, not even more, just little you have to think. Now let's get started. If m and n are natural numbers such that n is greater than 1 and m power n is this, then m minus n is equal to what? Okay, again I think this came in CAPF, from that I have picked. Now so if you see this, what you should do, pause and think first. Okay, I will solve it, but you pause and think that what is this, how can I break this, correct, how can I get m and n both are natural numbers. That means it must look something like this. Eventually it must look something to the power n. Can you feel this? Only one number can come here. Now how do I find that number? This is the question. Now see this, if I want this form, do I have anything in common here? So I write this is actually 2 power 5 into 5 into 3 power 8 into 5. Can you feel that power 5 is common both of them? Correct. So I can write it like this, 2 power 8 into 3 power 5 power 5. Sorry, opposite. 2 power 5 into 3 power 8 power 5. Can you feel this? So this is m power n form. So you have m also, you have n also, then m minus n is asked. Correct. You just start feeling by seeing the question. So this is n, this is n. What is the difference? So you can find out the value. This is what, 2 power 5 is 32 into 3 power 8. Again you will see that there is so much calculation. 3 power 8 is what? 3 power 8 is 3 power 4 into 3 power 4. This I can write. Correct. Now what is 3 power 4? 3 3s are 9, 9 3s are 27, 27 3s are 81. So essentially what is this? This is 81 into 81. This you got. This is the value of m. It is asking you m minus n. So what is minus n? So m minus n. So m I have written, and n is 5. Correct. Now see, you don't have to solve. I will tell you how you do this. That is important. That is important, that you don't multiply and minus 5. That will be very time taking. Now I have to take care of my words, that I don't start using anything now. So that will be time consuming. Now 2 1 1. First thing, you can figure out the last digit at least. Two options will be eliminated. Correct. So you see here 2 1 1. What is the last digit? Last digit is 2. What is the last digit here? 5. Now 2 minus 5. What will be the last digit? It will become what? 2 means it will become 12. 12 minus 5. 7. Correct. 7 is what you will get. Now first thing, you cancel these two options. Now you look here, if you see this number, this minus 5, this minus 5 is what is given in the option. That means, can you see that this number is divisible by 9? This number is divisible by 9. That means whatever is in option, if I add 5 to it, it must be divisible by 9. Can you feel this? Now if you can feel this, of course two options I have eliminated already. Now if I add 5, it should be divisible by 9. Now see, I am checking divisibility rule of 9. What is that? Create and cancel multiples of 9. So I cancel 9, 9, correct. Then 7 and 2 is also 9. Now 4 plus 5 is 9. That means this is divisible. So this is the possible answer. Now let's check D also. So 9, 9 cancel, 2 and 7 again 9, but 3 plus 5 is 8. Is 8 divisible by 9? That is why among A and D, A is the answer. Move forward in life. This is how you have to do this. Don't try to calculate. Okay, in most exams when they give you options, they also understand that you are not there to calculate things manually. Correct. So there are methods how you can do this faster. So understood. Always remember, I've told you the core rules: last digit, second last digit, okay, even, odd, prime, composite, and in this one what we have used is divisibility rules. Divisibility rule of 9 is actually very important. That is called the digital sum. Okay, so all these will help you in doing the questions faster. Okay, now let's do another one. 3 power 333 is divided by 11. The remainder is. We have done similar questions. Now see how I am doing this. So what I have told you, that you go powers of 3 and keep dividing it with 11 to find out if anywhere you get remainder as 1, or you get remainder as, let's say, minus 1. Both are okay with me. Now so I am trying now. 3 power 1 is, of course, remainder is 3 when divided by 11. 3 square is 9. 9 divided by 11. Again, remainder is 9. 3 cube. 3 cube is 27. Remainder becomes 5. What I am doing? 27 by 5. 27 by 11. What is the remainder? 11 2s are 22. So remainder is 5. Then 3 power 4 is 81. Remainder is 4. 3 power 5 is, now you may get confused with 243, correct, if you don't remember it, but this is very easy. Why this is very easy? Can you do this? 3 square into 3 cube. What is 3 square into 3 cube? 3 power 5. That means the remainder will be 9 into 5, correct? 9 into 5. What is 9 5s are? 45. Can 45 be remainder when divided by 11? No. So divide this by 11 again. 45 by 11. What is the remainder? 1. So that means essentially for 3 power 5k you get remainder 1. For 3 power 5k if you get remainder 1, now what you do? You break this down into 3 power 5k form. So what is the nearest multiple of 5 in 333? What is the nearest multiple of 5 near 333? 330, correct? So this becomes 3 power 330 into 3 cube by 11. This remainder I have to find. Now remainder you can multiply like this. 3 power 330, what will be the remainder? Remainder will be 1 in this case. So this remainder is 1 into 3 cube is what? 3 cube is 27, correct? 27 by 11, what is the remainder? 5. You can see from here also 3 power 3 divided by 11, 5 was the remainder. Answer becomes B, 5. Correct? Now, let me tell you another method. Okay. This will ease out this process. Okay, now see. This is called Fermat's little theorem or little Fermat's theorem, whatever. Now, so what you do here, if there is any number n, okay, if there is any number a to the power n and it is divided by p, where p is a prime number, and of course a and p do not have anything in common between them, that is they are co-prime, otherwise you will have to first cancel it out, correct? So then it is not in the lowest form. Once you get this structure, that is you have any number, of course not divisible by p, p is a prime number, and the remainder for this is asked. Understand that whatever is p minus 1, whatever is p minus 1, that will give you remainder 1. So here essentially what is p? Now I am writing here, see. So I am writing here, this is 3 power 333 by 11. I am trying to find out the remainder. Now, how many times will this go? It is not divisible. Now, p is a prime number. So it says that then a power p minus 1 will always give you that one remainder that you are looking for. Simple. So now here what you will get? 3 power 10 will give you remainder 1. This you can get to directly. It will take some time. Okay, once you identify that this is Fermat's structure, what you do? You write this number and to the power this minus 1. Correct? This is what you will get. So 3 power 10 will give you remainder 1. From here also you got 3 power 5 also 1. Then 3 power 5 into 3 power 5, 1 into 1, 1. Correct? So that is falling correctly. So if 3 power 10 gives you 1, same logic, what you will get? Remainder when 3 power 330 into 3 cube by 11. Why? Because 330 is a multiple of 10, correct? So I will divide. So this will give me remainder 1, and 3 power 3 again will give me remainder 5. 5 will become the answer again. This is using the theorem. If you remember the theorem, or you can go like this also, does not matter. Okay, then yeah, next, yeah, 10 power 68 divided by 13. Okay, now see, there are many ways to do this. I am telling you a very nice way that will make it very short. Now see, you are looking for power 1, correct? Now you're looking for power 1. Now here can you get power 1? So basically if you try to apply that little Fermat's theorem, what you will get is 10 power 12 gives you remainder 1, but that is not very helpful. Why that is not very helpful? Because 10 power 12 means nearest will be 60. 60 is not very useful to me. Why it is not useful? Because 60 will leave 10 power 8 still, correct? So not very useful. 10 power 8 is anyway a big number. Now see what I use instead. You can do this by going 13 powers also and get to the answer. I am giving you a better method. See, one thing I have taught you is special numbers. You remember 1001? Huh? What it was? 7 into 11 into 13. This you remember? 1001 was 7 into 11 into 13. Now, doesn't this mean that 10 power 3 when divided by 13 will leave remainder? What remainder it will leave? It will leave remainder 12 or it will leave remainder minus 1. That is using the concept of negative remainders, because 1001 is just bigger multiple of 13 above 1000. This is negative remainder. So what you got? Minus 1. That means now that means 10 power 3k, correct? 10 power 3 divided by 13 gives remainder minus 1. Now don't you think that means if I multiply this 2 times, that is 10 power 6 is what? 10 power 3 into 10 power 3, correct? This divided by 13 will be like minus 1 into minus 1. That means plus 1. What do you think? This will be what? Plus 1. That means 10 power 6k leaves remainder 1. Now the question is easy. What is it? 10 power 68. This can be written as 10 power 66 into 10 square by 13. What is 10 power 66? Multiple of 6. Remainder will be 1. Correct? And 10 square is what? 10 square is 100. 100 divided by 13. What is the remainder? 9. 13 sevens are 91. A becomes the answer. So you understood how I have used negative remainder. I didn't put it here. I could have, but then I have to think it is plus or minus or whatever. So what I saw that I can just directly go square of this. So I got 10 power 3 is giving me minus 1. Immediately I go 10 power 6. Otherwise what I will have to do, I can go by line also. Then I have to calculate for 10 power 4 also, 5 also, then eventually getting to 6. This is much shorter. Understood? And why you could use this? Because by God's grace you remember this. Understood? Okay, so this is it. So this is question number 8 now. Consider the following statements in respect of the sum p is equals to a plus b plus c, where a, b, c are distinct prime numbers. Okay, now in between 10 and 20, then you have to tell what are the possible values of unit digit. A very similar question has also come in UPSC. Okay, now when you see this question, pause and try. For people who are doing it directly with the video, pause and try. P is equals to a plus b plus c. Now essentially all these three belongs to prime number. This means belongs to, okay, that is these are prime numbers. Now also a, b, c are greater than 10 and less than 20, correct? So what are the possible values? First thing that you should do is, in one similar question we had seen that we had written all the digits that are possible from 0 to 9 and then we eliminated the cases. Similarly we will write all the possible values here as well. What are the possible values? 11 seems like a possible value, prime, and between this then 13 also seems one. 15 not a prime. 17 is a prime, yes. 19 is a prime. Then 20 goes beyond it. So essentially whatever has to happen with these four numbers. These are your values. Now from this, any three of them I choose, those can become my a, b, c. Now it is asking you about the sum p, which is a plus b plus c. So essentially how many ways can you choose it? Now if you know p and c, then this is what, how many ways can you choose three numbers from four numbers? 4c3, that is four ways, correct? Now if you don't know, then also intuitively you start picking any three or start leaving out one number. So first let's say I leave out 19, so this becomes 11 plus 13 plus 17. But even in this, focus that it is all the statements are only about unit digit. So I only care about unit digit. Now 1 plus 3 plus 7, what is the unit digit? 3 plus 7 is 10, that is 0. 0 plus 1, so unit digit is 1. So 1 is possible, yes. Next, now let's say I leave 17 this time, so this becomes 11 plus 13 plus 19. Now 9 plus 3, 9 plus 3 is 12, 12 plus 1 is 13. 13 means last digit is 3, so 3 is possible. Next, now I leave 13 out, correct? So now I have 11 plus 17 plus 19. What I will get? 9 plus 7 is 16. 16 plus 1 is 17. So I got 7 here, correct? Now 7 is not in the options, not in the statements. Fine. Then let's go next. So now finally I will leave 11 out. So what I will have is 13 plus 17 plus 19. So 9 plus 7 is 16. 6 plus 3 is 9. So 9 is also a possible unit digit. Is 5 possible? No. I have taken all the cases. 1, 3, 7, 9 is all the possibility. Now it is asking you which of the following given above are incorrect. Which is incorrect? Only 3 is incorrect because unit digit 5 is not at all possible. Okay, you can do it in many other ways also, but this is anyway very short. Also, in these questions, usually in the classes, all these crash course, foundation course, we are not able to take a lot of questions in which you have to try things. Correct? Because anyway, you have to attempt them later. So now in this, we are taking also the questions and you understand how you start trying things. So you understand from 4, if I have to choose 3, that means I have to leave 1. Correct? Leaving 1 is a much easier way to understand. So one side leave 19, one side leave 17, 13, 11. All the cases are done. Now, next. Again, very simple question. This is one number, is a 9-digit number, which is divisible by 72. Find the value of 3x plus 4y. Correct? What is this? Simple application of what we had learned, which was divisibility of composite numbers. Now, divisibility of composite numbers means what? 72. How you will check divisibility of this? By using two numbers which are co-prime to each other. 8 9s are 72. Are 8 and 9 co-prime? Yes. 8 and 9 are co-prime. They do not have any other common factor between them other than 1. So 8 and 9 is possible. So basically, if I can apply divisibility rule of 8 and divisibility rule of 9, if both of these satisfies, then I get the answer. Correct? Now, so you see it here. What is the divisibility rule of 8? Last 3 digit must be a multiple of 8. So that means 25y is divisible by 8. Now, if you see this directly, or if you remember at least 2 powers, then you would know that what is this? This is 2 power 8 is what? 256. Correct? 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 256. So 256 is definitely divisible. You can try to divide it also if you want to check. So this goes 3 times, 1 remains, with 16 it goes 2 times. Correct? So what I got? Y must be equal to 6. Correct? Because the multiple earlier than this will be 256 minus 8, which is 248. 256. Next would be 264. So with 25 you can only have 6 here. That means for sure the value of y is 6. Now let's try to find out the value of x. X, how will I find? So x, I keep it here, and then I have 1 7 6 8 4 2 5, and instead of y I am now writing 6. Divisibility by 9 was what? Create and cancel multiples of 9. So start cancelling out. So this becomes what? Let's start cancelling it out. So 8 plus 1 is 9. Correct? Then 5 plus 4 is also 9. Then 7 plus 2 is also 9. Correct? Then 6 plus 6 is 12. So let it be there. So that means 12 plus x has to be divisible by 9. What are the possibilities? What can x be? Now, x is of course positive and a single digit number. So one of the possible values of x is 6. X plus 6 will become 18. 18 is divisible by 9. Now, if I try to get to 27, then what I need here? I need here 50. Is that possible? No. It's a single digit number. So x is also 6. Now you have got both the values of x and y. It is asking you the value of 3x plus 4y. So essentially what you got is x is equals to y is equals to 6. Value that is being asked is 3x plus 4y. Essentially, if both are equal, so I can write it as 7x. What is the value of x? X is 6. So 7 into 6, 42 becomes the answer. That's it. Simple? Okay. Then, let's do this one. Yeah, 10th. This is what is the difference between the cube of the greatest single digit prime number and the cube of smallest 3-digit prime number. Now, why I have given this question is for you to understand that how can you find it in a much better way. So one normal way is, I expect that you can do this. So basically difference between the cube of the greatest single digit prime number. What is the greatest single digit prime number? Single digit prime numbers are 2, 3, 5, 7. Correct? Which is the greatest? 7. So essentially it is saying one of the numbers is 7 cube and the cube of the smallest 3-digit prime number. What is the smallest 3-digit prime number? See, 100 is the smallest 3-digit number, but is it prime? No. Then start checking for next one. 101. Is this a prime number or not? Correct. Now, if you get confused, what you have to do, basically, again, revise that. What you have to do, you have to take under root of 101. So it will come out to be 10 point something something. That means you need to check only for prime numbers less than 10 to decide that if it is prime or not. If it is not divisible by any number below 10, then you are assured that 101 is a prime number. So you can try 2, of course, not 3. 2 plus the sum is 2, so not 3. Then 5 is also not possible. 7 you can check. 7 ones are 7, 3 remains 31, again not divisible by 7 also. So that means 101 is a prime number and essentially the smallest 3-digit prime number. So what is the question? The question is fairly simple. This is the question. 101 cube minus 7 cube. This is the question. Now, see, one thing, you can find out the value and then do it. So let's do it using that also. 101 cube, can you find out? Okay, there are many ways. One thing is you can use a cube minus b cube, but that is itself lengthy. 101 cube is actually not that difficult to find. Let me show you how. This is essentially what? 100 plus 1 whole cube, correct? Now 100 cube is what? So 10 power 2, or here you will get 10 power 6, correct? 10 square cube. Then 1 cube is what? 1 plus 3ab. 3ab means here a into b is 100. So 3ab into a plus b, that is 101. Correct? So what you will get here is 2 zeros and 303. Correct? Now you can add it. So this becomes 6 zeros. 1, 2, 3, 4, 5, 6. Then add 30300 to it. What you got? 1030300. This is 101 cube and plus 1 plus 1 also. This plus 1. So this becomes 101 cube. Correct. Now you have to subtract what? What is 7 cube? 7 sevens are 49. 49 into 7 is 343, if you know. So this is 343. Now 11 minus 3 is 8. Then this becomes 9 minus 4 is 5. Then this has become 2. So 12 minus 3 is 9. Then this has become 9. Correct. And this has become 2 and 0, 1. So 102 9958. B becomes the answer. Correct. Now I won't suggest that you do it like this. This is a very calculative way of doing this. Correct. So instead, let's learn a better approach how you solve this. Let me write this question again. Let me put this again. Yeah. Here's the question again. Now, essentially, focus here. So what is being asked? Difference between cube of the greatest single-digit prime number and the smallest three-digit prime number. Correct. So essentially, this is very easily 7 cube I know is 343. Now 101 cube is what I don't know. Correct. Now see how I am doing this. So essentially, if I can tell the last two digits, that I will get, then I can get to the answer. Now see how I am getting to the last two digits. See, 101 cube is what? If I want to find out the last two digits, what I have to do? I have to divide this number by 100, and whatever comes out to be the remainder will give me the second last and last digit combined. Correct. For example, you take 225 by 100. What you get? What you get as remainder? You get 25 as remainder. What are the last two digits? 25. Correct. So that is why I have to divide this by 100. Now this is very easy. Correct. So what you will get is 101 whole cube divided by 100. What is the remainder? What is the remainder? 101. So remainder will come out to be 0, 1 itself. Correct. Can you feel this? 101 cube, I can directly divide it. It will become 1 cube. Or if you want to expand it, it will be like 101 into 101 into 101 by 100. Now divide all of them by 100. So this divided by 100 gives you 1 into 1 into 1. So what is the remainder? 0, 1 should be the last two digits. Now, if 0, 1 is the last two digits, correct, of this and 343, what is the last two digits? 43 is the last two digits here, correct. Now, what you have to do? You have to subtract them. This is what you have to do. So now what this becomes? 11 minus 3 is 8. Now this would have become 9. 9 minus 4, 5. So last two digits must be 58. Wrong answer. Understood? Okay, so this is why I told you this method where you can check the last two digits also. Usually in the classes we learn about how to find the last digit. Now you have understood how to find the last two digits also. So sometimes in questions which are calculative, this can help. Okay, with this we are done.